So, not too high. Recording? Okay, perfect. Okay, welcome to the meet and greet event session for this year. We have lots of projects, and I'm really pleased to introduce all of them. And I will just start maybe with a quick presentation of our team. I'm Philippe Rief. I'm responsible of research project at the Eclipse Foundation, and we have Marco Jan, who is here, and Susan and Maria Teresa, she's in Mexico, and we have also other people who are contributing to the research projects, like our Gail Blondel and Ralph Muller, who are contributing and helping us in. We used to name them our guest stars, and we have infrastructure support as well. And okay, we have a bunch of other people also from Canada and US who are helping us on these projects. You will see there are different kind of projects, but today we have mainly, I will say, it's easy to say, it's two main domains. Either it's in tools, obviously with Eclipse, we have often tools. IoT also, it's very, we find often requests to participate to these research projects, certainly because of the IoT community that we have in Eclipse, and we have some cross-domain projects, and I really like this kind of project where actually people have to talk to each other and participate, and we have several other projects in this area, so I will not go in details. So it's just to give you an idea, and now we will have our first presenter, first speaker, Luz, and she will talk to you about RobMoSys.
Thank you very much, Philip. Hi, my name is Luz Maria Martinez. I'm from the Technical University of Munich, and I work in the project RobMoSys. Well, RobMoSys is conceivable models for better tools and better software to achieve better robotic system, to reduce the complexity, better quality, and help to the developers to reduce the time of development. Also, we are a European project funded for Age 2020. We have principally two tools, SmartMDSD, that is work with the framework SmartSoft, that provide component development, software system design, and hardware architecture that you can see in the phone. Everything is working in Eclipse already. Also, we have Papyrus for robotics that is provide mostly the same component, but is framework agnostic, and have component development, software system design, safety analysis and control, and behavior design. We also offer open calls. We already have 2 open calls, but we have a second version of the second open call that is in the end of this month, the deadline. We have 2 parts. The instrument 1 that is for startups and small companies. That is 60,000 euros for a runtime of 6 months. Second instrument, that is instrument 3, that is mostly for experts. If you are an expert and you think it's useful for robotics, and we can include your research or your expertise in one of the tools, you can apply like an expert and you can receive 20,000 euros for a runtime of 6 months. Thank you very much. We received the proposal for the 31 of October. And now is turn of Harald Mack from Panorama.
So, thank you very much. I will introduce the Panorama project. It's an ITR3 project, so a European project. And you see the title, we want to accelerate design efficiency for heterogeneous embedded systems. We have a European project, as I said, 5 countries from Sweden, Finland, Germany, Portugal, and Turkey. And I don't want to read that all, but main idea is performance. So we want to deal with timing, scheduling, latency of systems, not the function of the systems itself. So it's more a question how to integrate the different things to one computer or to one car in that sense. The whole story began when multi-core systems were introduced in embedded systems. So we now had to deal with a new question to separate parts of the software that can run in parallel and to distribute it to different execution units. So that is meant by software distribution. And it was easy when all cores were more or less the same. This is now changing. We have more and more complex hardware. And the second step is you have to load the execution code, the program. You have to deal with data. So you have to read and write things, and that can be done in parallel from different cores. And so you have to optimize also the memory location to avoid unnecessary conflicts and long access times to data. This increases now because we see a trend to more and more complex systems. So let's say autonomous driving has a huge demand on computing power in future. That also means that functions that were separated on different electronic control units were now integrated into one, let's vehicle computer, or even distributed in the cloud. So we see more and more complex hardware and also very different application models. This is all in summary. So I already mentioned different domains. Hardware means we had formerly only microcontrollers. Now we have microprocessors, we have graphical accelerators, FPGAs, so very different things. And for example, microprocessors have multiple cache levels, out-of-order execution. So that all makes it difficult to predict the timing behavior. So connection to Eclipse. We established in the former projects an Eclipse project called App4MC, where we maintain a central data model that should handle all the performance relevant data. That is this MLTR model. And the idea is to be able to use this model for all kind of optimization, no matter if it's an open source tool, an in-house tool, or a commercial tool. And you also see support from some vendors for this data model already. So that's my part. Thank you for your part.
They're really good in timing, guys. I'm really impressed. Okay. Next, Ellis.
Well, good afternoon. I'm Ellis from Trialog, and I'm presenting PDP-4E. So this is also an H2020 project funding. And what is about this project? When it started 1.5 years before, I think that many of you, maybe all of you, remember that the GDPR entered in force. So this is what PDP-4E is about. We go from GDPR to engineering. Why? Because we are engineers. We are not lawyers. Maybe, thank God, sometimes. So how the GDPR will change the way you develop? I am compliant. I am not. All that kind of questions. Oh. What PDP-4E does? We provide tools in 4 different disciplines. And the 3 main objectives that we have is, first one, facilitating the privacy by design for engineers. So what we do is to integrate into the mainstream software the privacy and data protection. This way, we support engineers with privacy. How? With the open source strategy held by Eclipse. And also, which is most important, we really have to build community, to apply it, to spread over the results, and to really foster the creation of an alliance, no? So we can really use it in the whole community. Which are the 4 main disciplines, the 4 main tools we are providing is requirements engineering, model-driven engineer, risks management, and assurance and certification. As you can see, many of them are based on Papyrus, also Pharmacy for C code. The risk management tool is based also on Musa, and we use also methods for the tools to design. like Lindun or Propan, but we can say we have extended them. It was not sufficient for the GDPR. And here you have the integration that we can say that we provide like 4 different tools in 4 different disciplines, but they are like a toolkit they can act, okay? From the risk management, we can search the different threats, vulnerabilities, we provide the privacy controls, then we can model the different patterns for the systems. But which is more important also is, am I compliant? How can ensure you? So we have the assurance tool based on OpenCert that provides with evidences if you are compliant with this regulation, this ISO, different articles of GDPR. So we do this assessment in the whole life cycle of the process. And I will not extend too much, maybe. I'm not sure how many minutes I have consumed. So I will be at the stand and the exhibition. And I would like just to finish a bit with the progress and the results, because we've been just working 1.5 years. And we have done some milestones. The first design, maybe I'm not very close to the micro, sorry. The design of the architecture and tools, and the first release of the tools will be, we can say, by next month, at the beginning of next month. Not yet available in Eclipse, but we hope to have it available very soon, or at least soon. And one important point is that we will validate our results in 2 different demonstrators in 2 different domains, which is the connected vehicles and the big data on the smart grid. So we really will have like the next milestone of first validation with engineers. So if you are here, a lot of engineers, please just come to visit me, and I will be very pleased to, you can help me and I can help you. So it's okay for the minutes, so I don't extend more. Okay, and just, well, maybe the last part, you can see the different members of the consortium. Okay, so thanks. And the next one is Jörg Tesma. Jörg. Okay.
Thank you very much. Mr. Stressmer.
Thank you. Okay, then I will start with the next one. That project is called, CUXA is named here, that's the Eclipse project. The official publicly funded project is Abstackle, which is relevant for communication between a vehicle and the cloud. So we make really a coupling between IoT stuff and the vehicle as a device. So therefore, if we're looking for a solution on that, we are currently 21 partners out of 4 countries. And unfortunately, the project is running out by end of December. So we are in the final step of getting everything ready. What is it all about? So if we see, we have Eclipse IoT and we have a vehicle. And then the outcome was, what can we do with that? It was CUXA. We figured out with the name Abstackle, we couldn't do that because it's trademark issues on the Eclipse side. So, and we didn't want to reinvent everything again. So we said, okay, we built on top of existing technologies what is available from the Eclipse side. So we have now a cross-vendor application for on the cloud side, and also within the vehicle we published certain informations which are standardized and publicly available. So there's no really fancy new things on it. And if you see what all projects or all related projects we used within CUXA, then you already see all the people who are aware of the IoT stuff. They see that there are a bunch of things used. So we have 3 main pillars in there. That's one is the in-vehicle side, which represents the device and where we make the coupling between a Linux operating system, putting some things on top for getting the data out and to the vehicle, and we also doing a kind of that you can download applications to the vehicle. So we're using Docker, for example, that you can put in containers onto the vehicle itself. The other thing is the IDE possibility. So we have built on Eclipse J an IDE, which can be used for creating your applications you want to run on the vehicle or even in the cloud. It doesn't matter, whatever kind of things you want to do with the data you get from the vehicle or you want to calculate in the vehicle, you can do that and create your own applications based on that. And we have that entire cloud platform where we combine security stuff with Keycloak. We have that deployment part with Hawkbit. We have the communication channel with Hono. Those Eclipse projects we combined in there and made that to a common infrastructure. Just some small explanations, but in here, everyone can see that. We are not, the only thing what I mentioned, we are just focused on a Linux-based system on the vehicle, which is mainly the part where, for example, the infotainment is running in the vehicle. So those things are most likely Linux-based systems. So we can put it based on AGL, the automotive-grade Linux platform, or Apertus, which is a Debian platform, or even Ubuntu. We can, our system runs on that. Just a small graphic how it is connected. So you have that IDE, you have that in-vehicle platform, and you have that entire cloud system for collecting those data. And we also represented a combination from cloud to cloud representation so that you can connect two different clouds together to exchange data. For example, if OEM has its own cloud and wants to get those data to another one because they want to do certain things, we also realize that. And if you want to see that in reality, we have a place on the IoT playground in front of the theater where we have our demonstrators available where you can play around. We have that small rover which can be controlled. We have a bigger one where it should kind of represent a vehicle where you can control a throttle valve and stuff like that. And we even have some hardware which you can plug in your own car and collect your data, which is, from some people already know, if you have a mobile phone, then you can do that via Bluetooth. Here we have a standalone application which has an LTE GPS stuff on it, a Raspbian compute module where you can also deploy your own applications by yourself, created by yourself. So just visit us there and then we can go more in details.
Thank you. Thanks a lot. Okay, next. CrossMiner.
Hi, I'm Boris Baldassari. I work for Castelia Solutions, and I'm going to introduce CrossMiner, which is another EU-funded research project through the H2020 program. So what we do with CrossMiner is we mine data from a series of sources along the software development process. So we plug into the various tools that we have: software configuration management, bug tracking, system configuration files in the Git repositories, mailing lists, forums, and so on. And so we get this data, we analyze it, we provide dashboards, we provide recommendations about how you could improve your project. One distinguishing characteristic of CrossMiner is the intensive usage of natural language processing techniques. So we analyze everything that is natural language, comments on issues, message in commits, mailing lists, forums, and so on. And we have a sentiment analysis, polarity, so we can say that we can tell if the project has a good support, if people are happy with that. And so it's meant to be used both by the project managers and developers to know the health of their project and know how they can improve their project, and also for people who are looking for a project to use or reuse, help them select a project that is active, that is sustainable, and so on. Here is an example of the dashboards that we provide. So this one is about NLP processing. So we have the emotions, you have the surprise, joy, love, sadness, anger, and fear. You have the evolution of the emotions along the time. So that's really interesting. As an example, that happens that in the beginning of the project there is a bit of a lack of support, so people are a bit angry about that. Then people start better supporting their users, so the joy and the happiness gets better and so on. So that's really interesting to have this kind of insight on the project. Another deliverable and byproduct of CrossMiner is the publishing of a series of open datasets related to the Eclipse Forge. So we have a dump of all mailing lists hosted at the Eclipse Forge. We provide also the ARI dataset, which is a list of exceptions encountered by users in the Eclipse IDE, so which are automatically retrieved and centralized. That is already used by people to know what are the problems in their plugins, but that can be used by that is used also by different research labs around the world. And we also have a series of data related to each project with everything from commits, bugs, mailing list, messages, and so on, all in an easy-to-use form, CSV file. And you have instructions about how to read them and so on. You also have a quick analysis, R Markdown for those who know that tells briefly what the evolution is and so on. All data is anonymized to preserve the user's privacy, and it's all available on the datasets website, so on downloadeclipse.org. You also have here the eclipse.org Scava project. Scava is the Eclipse project of the CrossMiner EU project. And you also have, of course, the CrossMiner website. Please join us. We will have soon a workshop upcoming to better know and discover CrossMiner. So please get in touch with us, Philip Grief, and myself. Thank you.
Thanks, Boris. Hi, guys. My name is Krzysztof. I am from DAC. It's a software house in Poland, and I'm here to talk to you about project Arrowhead Tools. It's another European project. We have participants from over 18 countries, and number-wise, I think we are quite big. We have 80 partners, and the budget is over 90 million euros. Project is scheduled for 3 years. We have great partners from Bosch. We have partners from Infineon, ST, Philips. So what are the challenges that we're trying to solve? First, we would like to reduce engineering costs. The ambition is to go as low as 20 to 50% when we are talking about IoT and a system of systems automation. We would also like to introduce tool chains that will support this entire process. And we also strive to provide efficient training for engineers in terms of our platform. What's the motivation? Well, the value is shifting across cyber physical systems, and by 2025, 2/3 is going to be captured downstream. That's what we believe. And how do we go about this? By SOS industrialization. We need engineering tools. We need to provide tools that are going to facilitate that. We have identified 21 use cases that we are trying to tackle. And I will tell you about one of those use cases. We call it autonomous provisioning of local clouds. It's basically trying to introduce Steve Jobs' philosophy into engineering world. We would like to make applications and software usable and friendly to people that are not directly involved in engineering. So you can imagine that someone in a warehouse is trying to introduce new parts to a local cloud landscape, a new IoT part. How do you onboard this part securely and intuitively? So the idea is that we can scan private keys or public keys of that card using NFC or using a QR code, record it in a local repository, and then while onboarding the device in a local cloud, it's going to automatically link with the entire cloud and exchange data and share its state. We see the bigger picture, of course. DLT is becoming more and more relevant. So how can we onboard an IoT landscape in a bigger picture? Well, by trying to oracleize it. So that's our vision, and that's where we are trying to go. Thank you very much, and now I'll hand over. Thanks so much.
I'm just amazed, guys. You are really perfect on time. I'm gonna do it. It's good.
My name is Enrico Ferreira. I'm the coordinator of Brain IoT project. I work for Links Foundation. So basically, what is the motivation for Brain IoT is basically that nowadays the IoT systems are getting more and more complex because of the higher numbers of devices and services which are interconnected among each other in such a complex scenarios such as smart cities. And what Brain IoT wants to do is basically to reduce the effort for developing IoT applications, and from different perspectives. One is the design. One perspective is the design of the IoT application, and in these regarding these, we are defining a modeling language that is basically dedicated for IoT. Then we are deploying a runtime infrastructure that is flexible enough to respond to external events and how to configure itself. Then we are proposing some approaches for the assessment and decision support system for the developers in order to be compliant with the regulation with regard to the security and privacy, such as GDPR. And at the end, we want to connect these models with the concrete implementations and reusing as much as possible the existing services, IoT services which are already implemented. We don't want to re-implement the wheel again and again. We are testing this platform in mainly two scenarios, which are service robotics and critical infrastructure management, more specifically in the context of the management of a water infrastructure that is used, the water distribution infrastructure that is used in Coruña city. The flow is basically that first we design our architecture and the behavior which orchestrates these services, and we generate the code when is needed, if it's not already there, or otherwise we reuse what the IoT market, the IoT domain already provide. And basically, we want to translate the model to a system description that is fed in our runtime infrastructure, and this runtime infrastructure can basically deploy the relevant software artifacts and also the adapters needed to talk with external IoT services in a dynamic way. And it can react to external critical events, such as security attacks, or nodes failure, in order to be more to keep the system running and to continue the service which are meant for. And our solution, it is based on SensiNet, which is an Eclipse project, and Papyrus. It's based on OSGI, and also the runtime infrastructure is based on Paremus Service Fabric, which have been presenting in these days in the OSGI event. There are much more details that we can provide, and I suggest you to go to the website brainiot.eu, and if you are interested, you can subscribe to our newsletter. Thank you.
So we went through all this presentation, and first of all, I would like really to thank you all these speakers, and thank you for doing this job. So please close. Yeah, so for your information, we are located here. So you will see you see the theater. So we have our research booth is located here, and as well we are also part of the IoT playground. So please come, and if you want to have more details on any of these projects, on all of these projects, we have flyers, we have stickers, and we will be happy to give you more inputs. Okay, thank you very much for attending. Bye-bye.